Good morning all. In this session we are discussing about number systems. Number systems are ways or methods to represent numbers using symbols or digits. Now we will discuss about the types of number systems. Types of number systems. Mainly there are 4 types of number systems, and they are decimal number systems. Decimal. Second one is binary number system. Third one is octal number system, and the fourth one is hexadecimal number system. Now we will see one by one. Okay, first one is decimal number system. The literal meaning of deci is 1 by 10th. 1 by 10th. Okay, you might have noticed that the word decimal actually comes from or is derived from the small or smaller word deci. Okay, it just means 1 by 10th. Okay, here the word deci actually stands for 10. Okay, and the reason or the reasons why it is known as decimal number system are: the first reason is it uses 10 symbols. 10 symbols are used. And the second reason is its weight or base is in tens. Now we will see what is meant by the 10 symbols. 10 symbols. Which are the 10 symbols or digits used in a decimal number system? It is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Altogether it is 10. This is 0 will be the first digit or first symbol, and 9 is going to be the 10th symbol. If you count, we will be getting 10 symbols. It just means any number in the decimal number system consists of any of these symbols or digits. For example, if you let us take a decimal number 1, 4, 5, 6. It just uses the digits 1, 4, 5 and 6. And let us take another example. Let us say 7, 8, 9, 1, and we call this number as 7891. It has just used, you see, 7, 8, 9 and 1. So any number in the decimal number system is going to use these symbols or digits. If we put in another words, every decimal number consists of any of these symbols, or it is a combination of these symbols. So that is the first reason. The second reason is the base is in tens. That is, usually the decimal number system is represented as you see in the screen. This is the way in which decimal number system are represented. It just means the base is 10. What is meant by base or weight? You see, we will try to understand with an example. This is actually called as 184. That means this is 10 raised to 0, this is 10 raised to 1, this is 10 raised to 2. Okay. Any number raised to 0 equal to 1, we know. So 10 raised to 0 also equal to 1. And 10 raised to 1 equal to 10, 10 raised to 2 equal to 100. So this position actually stands for ones, that is the 4 stands for ones, and 8 stands for tens, and the 1 here stands for 10 raised to 2, that is 100. That is why it is called as 184. Okay, so the base, the positional weight is in 10. That is why we call, or it is known as the base is in 10. Okay, let us take another example. Let us take this number, and we know it is called as 3843. This position actually stands for 10 raised to 0, this position 10 raised to 1, this position 10 raised to 2, and this is for 10 raised to 3. And as we have already seen, this position indicates ones, or 10 raised to 0 is 1, this is 10, this is 100, and 10 raised to 3 is 1000. Okay, so it is called as 3843. This stands for ones, this 3 is actually standing for ones, this is for tens, this is for hundreds, and this is for thousands. So you might have understood why the base is in 10. So suppose we just take another example. Let us take a larger number. So again, how will be the base progressing? This is 10 raised to 0, this is 10 raised to 1, this is 10 raised to 2, this is 10 raised to 3, this is 10 raised to 4. So that's the way in which the weight goes. So the reasons why it is known as decimal, there are only 2 reasons. The first thing is it uses 10 symbols, that is 0 to 9, and the second reason is it uses, or it has a base of 10. Hope it is clear for you. We will discuss about binary number systems. The word binary means consisting of two things. So it is related with the number 2, or let us say binary stands for 2. The reasons why it is known as binary number system is similar to that of decimal number system, whereas in decimal we used 10 symbols. Here we are going to use 2 symbols. So the first reason is binary number system uses 2 symbols or digits, and those digits are zeros and 1, zeros and ones. So a binary number will consist of only 2 symbols. So a binary number will look like this. Okay. So the first reason is it uses 2 symbols or digits, and the second reason is the base is in 2. The base is in 2. Okay. So we will see a binary number example. This is an example for a binary number. So this position stands for 2 raised to 0. This position is for 2 raised to 1. This position is for 2 raised to 2, and this position is for 2 raised to 3. So as we already understood, any number raised to 0 equal to 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8. So the decimal equivalent of this particular binary number is actually 8 plus 4, 12 plus 1, 13. So this number, that is 1101, this binary number is equivalent to decimal number 30. Anyway, we will discuss about the conversions, that is how a number in a particular number system is converted to another number system. We will be seeing in the next class, but for the time being it is enough to understand how these number systems are represented. So in a binary number system we will be using only two symbols, that is zeros and ones, and the base or the weight is in 2. Hope that is clear for you. Now we'll see the next number system. Okay, now we will discuss about octal number systems. The word octal stands for 8. Octal stands for 8. So the reason why it is known as octal number system, it uses 8 symbols or digits, 8 symbols or digits, and the second reason is base is in 8. So we'll see the first reason in detail. It uses 8 symbols, and which are those 8 symbols? It is 0, 1, 2, 3, 4, 5, 6, 7. So we know it is 8 symbols. 8 symbols. 0 is the first one, then 1 is the second one, and 7 is the 8th symbol. So an octal number will look like this: 153 to the base 8. And let us see another example: 761. Yes, this is a valued octal number because it uses only symbols within 0 and 7. Okay, so this is a valued octal number. And what about this one, 962? Is it a valued octal number? No. What is the reason? This 9 does not belong to the symbols which are supposed to be used by the octal number system. So this is not a valid octal number. Okay, and the base is in 8. So this is similar to the previous number systems. Let's take the example of 153. So this position is for 8 raised to 0. This position is for 8 raised to 1. This position is for 8 raised to 2. That's the way the base progresses. Okay, so anyway we will see the conversions later, so we are not going to see the decimal equivalent here. Anyway, we will be seeing it in the next class, the conversions. So an octal number system uses 8 symbols and the base or the weight is in 8. Now we will discuss about hexadecimal number systems. The word hexa means 6 decimal stands for 10. So whole together it means 16. 16. The reasons why it is known as hexadecimal is it uses 16 symbols and the base is in 16. So these are the two reasons why it is known as hexadecimal number systems. Which are the 16 symbols used in hexadecimal? The first 10 symbols of decimal is used in the same manner, that is 0 to 9. Okay, so we will write here decimal and hexadecimal. So decimal 0 is hexadecimal 0 to 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7, 8 is 8, 9 is 9, 10 onwards it changes. Decimal 10 is hexadecimal A, 11 is B, 12 is C, 13 is D, and decimal hexadecimal, which I am denoting it as HD. So 13, decimal 13 is hexadecimal D, then decimal 14 is hexadecimal E, then decimal 15 is hexadecimal F. So if you count whole together, there are going to be 16 symbols. 0 to 9, 0 to 9 is 10, then this is 11th symbol, this is 12th symbol, this is 13th symbol, this is 14th symbol, this is 15th symbol, and this is 16th symbol. So the first 10 symbols, that is 0 to 9, are used. Then 10 onwards it has A, B, C, D, E, F. 15 is the last symbol, that is F is the last symbol used in hexadecimal. Okay, now we will see how the base goes. A hexadecimal number will look like this: 1 AB to the base 16. But we know that this B is not the B as such, it is actually 11 in decimal. So this is A is 10, we know 1 is 1. So the positional weight or the radix or the base, so remember for the base we make use of the word weight, radix, as well as positional weight. So these things are same weight. These things are same. So coming back to the hexadecimal number, this position is 16 raised to 0, this position is 16 raised to 1, this position is 16 raised to 2. But remember, B is actually decimal 11, A is 10. So now we will see one more example. Let us say 2FA. Again, this position is for the weight 16 raised to 0. This position has a weight 16 raised to 1. This position has a weight 16 raised to 2. So to conclude, the positional weight is in 16 and the number of symbols used are 16. Hope it is clear for you. Now we'll go to the next number system. Now, okay, let us take another example.